Hello everyone. In the previous video, we had these statements being defined for the MN flip-flop, and then we used those statements to fill in this table here, which is the table for the present state and the next state of this MN flip-flop. Now, in this video, we will go ahead and do the second part of this problem, problem 12.9, which says that using this table that we already have, it wants us to derive and minimize the input equations for a counter composed of 3 MN flip-flops, which counts in the following sequence. So the sequence that we have, so here we want to design a counter using 3 of these MN flip-flops. So 3 MN flip-flops. Okay, and it says that it counts in this sequence. So it is CBA is equal to 0, 0, 0. So this is the sequence in which the counter is counting. Okay, 1, 0, 0, and then here we'll go back to 0, 0, 0. So here we have repeat. Okay, so we want to use these MN flip-flops in order to design this counter. All right, okay, so let's see how we can do that. So the first thing is that we know that the counter, it has 3 MN flip-flops, and we know that C, B, and A are 3 outputs of these 3 flip-flops. So we have 1 flip-flop counting for C, 1 counting for B, and 1 counting for A. Okay, so if we have a table over here, so for now, we only want to fill in these 2 first columns of this table. So we have C, B, A, and then we have the next C, next B, and next A. So we know that when we have the flip-flop, we're going to have some next states, right? Okay, so let's see what is the sequence for CBA. It is 0, 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 1, and 0, 0, 0, which is the last, which is repeating the same sequence. Okay, so now that I want to fill in for C plus, B plus, and A plus, for example here, when we are at 0, 0, 0, what is the next state that the counter will count? You see it is here. So we have 0, 0, 1. When we are at 0, 0, 1, what is the next state? So this is my present state. I know that my counter will count 0, 1, 1 as the next state. Okay, so we will fill out this table. 1, 0, 0, and then 0, 0, 0. Okay, so I'll just delete this 0, 0, 0 because we don't want to repeat the table here. Okay, now, so I have the next state for each flip-flop. What the question was asking us was to find the equations for the inputs of each of these flip-flops. The inputs of the flip-flops are M and N. These are the inputs to the M N flip-flop. Okay, so when I want to find the M N equation for each of the flip-flops, it means that each of my flip-flops, they have one M and one N, right? So I have MC and C, MB and B, MA and NA. Okay, so here, when I fill out this table and find all possibilities for M and N for each of the flip-flops, then I can draw the Karnaugh map for each of them, and using the Karnaugh map, I can find the equation for each of these inputs. All right, so now here, what I have to do, I have to get some help from this table up here, which I have done in problem one, the part A of this problem, and also what I have for the present state of my counter and the next state of my counter. Okay, so let's do it one flip-flop at a time. Okay, so I'll do one flip-flop at a time. Okay, so see, you can use I mean you can see here that we have the present state of the flip-flop is 0. The next state is 0, right? So 0, 0. I'm looking at flip-flop C, right? I go up here to this table, so I can call this as table 1, so I can refer to it. So in table 1, I see that whenever I have the present state equal to 0 and the next state equal to 0, mn is equal to 0x, right? So I have 0x for flip-flop C. Now, let's look at the same row, but for flip-flop B. So again, I have 0, 0. So the present state is 0, the next state is 0, right? So again, I'm going to have 0x. Then for MA and NA, which are for the inputs to flip-flop A, when we look at here, I have the present state equal to 0, the next state equal to 1. So I have to go back to table 1. I have the present state equal to 0 here, and the next state equal to 1. So what would be my mn? It is 1x, right? So I have to do this for all the rows of this table. Okay, so let's do it together. So now I know that wherever I have 0, 0, we have 0x. Whenever I have 0, 1, which is for B, so now I'm in row 2. Okay, so B is 0, B plus is 1. So for 0, 1, in table 1, we had 1x, right? And then for A, we have 1, 1. So if I go up to table 1, I see that if the present state is 1 and the next state is also equal to 1, mn would be x1. Okay, now we go to row 3. So I have 0, 1 for C, 0, 1 is 1x. I have 1, 1 for B, so I have x1, and I have 1, 1 for A. So we're going to have x1. Then we go back and consider row 4. So we have 1, 1, so it is x1. Then I have 1, 0. So in this table, in table 1, for 1, 0, we have x0. And then for 1, 1, we're going to have x1. We go to row 5. So for C, we have 1, 1, which is x1. For B, I have 0, 0, which is 0x. And for A, we have 1, 0, which is x0. And the last row, for C, we have 1, 0. So mn will be x0. For B and A are both 0, 0. So we're going to have 0x and 0x. Okay, so now I have all the possibilities for M and N for each of the flip-flops. So I can draw the Karnaugh map for each of these flip-flops and then find the equation for M, N, and also the next state of the flip-flop. Okay, so let's draw. So each of my flip-flops, each of them has 3 different Karnaugh maps. So I need 9 Karnaugh maps total. So here we have this is for flip-flop C. And the third one. Okay. So one of them is for C plus, one of them is for MC, and one of them is for NC. So we have C, B, A, and I'm writing them in this sequence, CBA, because I know that the sequence that I'm counting in is CBA, so that would be easier to find the cell that I want to fill it in. All right. So for C plus, what should I look at for C plus? I should look at this column of this table, right? So CBA, all are 0, C plus will be 0, which is this cell. When I have 0, 0, 1, we have C plus equal to 0. So 0, 0, 1, we have 0. Then 0, 1, 1 will be equal to 1. Then 1, 1, 1, we have 1. And then 1, 0, 1, we have 1. And 1, 0, 0, which is this cell here, we have 0, right? So you see that we don't have anything here, so we don't care about the value of C plus at this cell. Then we go for MC. So for MC, we are looking at this column here. So we have 0, 0, 0. MC is equal to 0, 0, 0, 1. We have 0. 0, 1, 1, we have 1. For 1, 1, 1, we have X. For 1, 0, 1, we have X. And for 1, 0, 0, we also have X. So here at these two cells, we're going to have X as well. Okay? So now we have to fill in the Karnaugh map for NC. For NC, we are looking at this column over here. So for 0, 0, 0, we have X. So you see, we are looking here at CBA, and then we are looking at this column, right? So for 0, 0, 1, we have X. For 0, 1, 1, we have X. Then for 1, 1, 1, we have 1. For 1, 0, 1, we have 1. And for 1, 0, 0, we have 0, right? And then these last two will be equal to X. All right, so if I want to write the equations for the inputs of these two flip-flops, for flip-flop C, I can just write the equation that I can get from these Karnaugh maps. So for MC, I'm going to have B. So MC is equal to B, and NC will be equal to A. All right, so we found the equation for MC and NC. And also for C plus, we have it over here, right? So for C plus, if I want to write the equation for C plus, you can see that I have these four ones here and these two here. So my C plus will be equal to CA plus B. Okay, so this was for flip-flop C. Then let's do it for flip-flop B. And at the end, we'll do for flip-flop A. All right, so I'm going to draw 3 more flip-flops here. Karnaugh maps. So we have to do the same procedure as we did for flip-flop C. Now we have to do it for flip-flop A and B. So now I'm doing flip-flop B. So we have B plus, MB, and NB. So we have 0, 1, 0, 0, 0, 1 here. So the same procedure as we were doing before for flip-flop C. Now I will do everything for flip-flop B. Okay, so what I have to look at is CBA, the present states. And for example, for the first one, for the first Karnaugh map, which I want to find B plus, I have to look at this column, right? So for 0, 0, 0, we have 0. For 0, 0, 1, we have 1, 1, 0, 0, 0, X. Oops, actually I was wrong here. I had to put these numbers in the first Karnaugh map. So it was supposed to be in the first one because I was reading the column for B plus. Okay, so let me fill it again. So we have 0, 1, 1, X, 0, 0, 0, X. Okay, so this was for B plus. Now, what I have to look at is this column over here, which is MB. So for 0, 0, 0, we have 0. For 0, 0, 1, we have 1. For 0, 1, 1, we have x. For 1, 1, 1, we have x, and 0, 0, x, and x. So how am I filling this? Again, I'm looking at this column over here, MB, and these three columns over here, which are my present states. Okay, now for NB, I have to look at this column over here. So for 0, 0, 0, we have x. For 0, 0, 1, we have, again, x, 1, x, x, 0, x, and x. Okay, so we found, we filled in the Karnaugh maps for flip-flop B. Okay, so I have to write the equation for each of these. So this is the equation for B plus. So B plus is equal to C prime A. Then what is MB? So if you look at here, we're going to have C prime A. And then over here for NB, I can group them like this. And this is equal to C prime. All right. Now the last flip-flop that I have to find the equations for, the input equations for, is flip-flop A. So I have to fill in 3 more Karnaugh maps. So I will just do it here. So 1 Karnaugh map for A plus, 1 Karnaugh map for MA, and the last Karnaugh map would be for NA. So we have C, BA, C, BA, and C, BA. So I'll write this over here. So B plus is equal to, I just want to erase this so it won't get confused. 0, 1. All right. So let me just take this also here. Okay, so this is for A plus, this is for MA and NA. All right. Okay, so for A plus, we have to look at which column? We have to look at column A plus. So for 0, 0, 0, we have 1. For 0, 0, 1, we have 1. 0, 1, 1 is 1, 1, and then 1, 0, 1, we have 0. And 1, 0, 0, we have 0. So we're going to have x and x here. Then for MA, I have to look at this column over here and fill the Karnaugh map with respect to that. So I have 1, x, 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 0, x, x, and x. And for NA, we have to look at this column over here. So we're going to have x, x, 1, 0, 1, 1, x, and x. Okay, so now again, we have to write the equation for each of these Karnaugh maps. So for A plus, I'm going to have the first group, the vertical one, we have C prime plus, and this square one, we're going to have B. Then for MA, I have the loop over here, so which is equal to C prime. And NA would be equal to this one over here and this one. So we're going to have C prime plus B. All right. Okay, so we constructed this counter. So first I did the table for the counter. So we wrote the present state, then the next states, and then we know that we are using 3 different flip-flops. So each flip-flop is counting one of the digits, C, B, and A. And then we drew the Karnaugh maps for all these flip-flops, and we found the equation for each of them. All right, so I hope you understood this question well. If you have any questions, you can leave it in the comments down below, and see you in the next video. Thanks for watching.